All right, guys, good morning, good afternoon, good evening. Welcome back to another video. We spent the last couple days talking about factoring quadratics. 8.1.3 in the notes today is another look at the fast way of factoring quadratics. So it starts off with some math notes. The math notes start off with a standard form of a quadratic expression. It says a quadratic expression in the form ax squared plus bx plus c is said to be in standard form. Notice that the terms are in order from greatest exponent to least exponent. So if you go to ax squared plus bx plus c, notice that the x squared is the biggest x to the biggest power. That's going to go first. Then we have x to the first. That's the next biggest power. It goes second. And then notice c doesn't have any x's. So technically that's x to the 0. So that would go last. So we call this standard form. You should always try to put quadratics in standard form. Again, quadratics is just a fancy way of saying something with an x squared. So it says examples of quadratic expressions in standard form are 3m squared plus m minus 1. Notice the m squared comes first, then m to the first, then no m's and then negative 1. X squared minus 9 is in standard form. Notice it doesn't have an x to the first power, but that's okay. We still have x squared first and then the negative 9 come in second. We also have 3x squared plus 5x. The x squared term comes first and then the x to the first term comes second. But notice there's no constant term or a number by itself, and that's okay as long as it's in order. So let's dive in. The last section we talked about factoring these kind of expressions using the diamond problem in a generic rectangle in kind of a fast way or a fast method. So let's try to do the same thing here. So I'll fold the paper so that I have some space to work. Hopefully the assignment went well. If not, feel free to reach out to me. We can talk about it over Google Hangouts, and maybe then I can explain it kind of face to face if you're having some trouble or not sure what's going on. All right, guys, let's dive in. How about 8-24? So in part A, it says, can I factor the quadratic expression using a diamond problem and a generic rectangle? So how about for A? Here we have x squared plus 6x plus 9. Notice how it's in standard form. We have the x squared first, the 6x to the first next, and then the 9 at the end. So then for part A, just like we did the other day, I'm going to make a box. So I call that the generic rectangle. And then I'm going to make the x, which you could also make a diamond. And in this case, remember that I'm looking for two things to multiply to the top number and then add up to the bottom number. So inside of my generic rectangle in my box, I can fill in my quadratic term. So the x squared will go on the bottom left. I can fill in the constant term, which is positive 9, and that can go in the top right. So it'll be like this. I know that if I want to find these two values that should be sitting here, they should both be something with x's. And I know that this diagonal should multiply to the same thing as this diagonal. So what does this diagonal multiply to? Well, what is x squared times 9? It would be 9x squared. So the 9x squared will go onto the top of this. You could also make this into a diamond, like the diamonds that we've been seeing in the assignment since back to semester 1. Now I know that these two x values that are missing here should also add up to something. They should add up to whatever is here in the middle. So then here I have a 6x, so then 6x will go down here below. So I'll start with the multiplication. Do I know two things that multiply to 9? Well, there are only two possibilities. Things that multiply to 9 are either 3 and 3 or 9 and 1. So in this case, I'm looking for those two things to also add up to 6x. So would it be 9 and 1 or would it be 3 and 3? In this case, it has to be 3 and 3. So I'll go 3 and 3. Well, how can these two things multiply to 9x squared? Well, I can give each one an x. So this would be a 3x and this would be a 3x. So before you continue, you should check it. Is 3x times 3x 9x squared? It is. Is 3x plus 3x 6x? It is. So then I can fill in a 3x here. I can fill in a 3x here. Again, it doesn't matter the order that you fill them in. In this case, it wouldn't make too much of a difference because they're both the same. But if they were different, it wouldn't matter which place you put them in. So now let's talk GCFs. How about going this way? Well, what's the biggest thing that 3x and 9 have in common? The biggest thing they have in common would be 3. I can't take any x's because 9 doesn't have any. Because this 3x is positive, this 3 would be positive as well. How about going this way? What's the biggest thing that x squared and 3x have in common? The biggest thing they have in common is x, and it's going to be positive because x squared here is positive. How about going down this way? What's the GCF of 3x and x? Well, it's going to be x again. How about the GCF of 3x and 9? It's going to be 3. And because this 3x is positive, this will be positive as well. So how can I write this factoring as a product? Well, I know that the area for this rectangle is either adding up all the inside as a sum, or it'll be the product of the length times the width. So in this case, the length is x plus 3. The width is x plus 3, so if I put them next to each other in parentheses, that implies multiplication, but they are the same set. So if I wanted to, I could rewrite this as x plus 3, and then if I multiply anything by itself, that means the set would be squared. So final answer, x plus 3 squared. All right, guys, if you want to pause the video and try some of the other ones for yourself, you can do that, and then you can play the video just to check your work and see if it made sense. So let's do that now. Again, you can do this on a separate sheet of paper. It doesn't have to be printed on this note sheet. Otherwise, I'm going to keep diving in. All right, so let's go to part B. We'll start in a similar fashion. We'll make a box, or a generic rectangle as they call it. We'll make an X. This would be like the diamond. I want to find two things to multiply and two things to add. So I'll fill in what I know. Quadratic term goes in the bottom. This is the 2x squared. The constant term is the 3. That's going to go in the top right. So I know that this diagonal should multiply to the same thing as this. So what is 2x squared times 3? Well, 2x squared times 3 is 6x squared. I know they need to add up to what I have here. So this will be 5x. So now I'm thinking to myself, what are two things that multiply to 6 and add up to 5? Well, the only thing that doesn't multiply to 6 are 1 and 6 and 2 and 3. It can't be 1 and 6 because they would add up to 7. So in this case, it has to be 2 and 3. So it'll be a 2x and a 3x. Let's just double check before we move on. Is 2x times 3x 6x squared? It is. Is 2x plus 3x 5x? It is. So in this case, I can go with 2x and I can go with 3x. Again, like I said, it doesn't matter if I put 3x here or 2x here. The final answer will still come out to the same thing. So let's go GCFs. What's the GCF of 2x and 3? Well, the biggest thing that 2 and 3 have in common is 1. I can't take any x's because notice 3 doesn't have any x's. Because this 2x is positive, that means that this one is going to be positive as well. How about going this way? What's the GCF of 2x squared and 3x? Well, the GCF of 2 and 3 is just 1. But how many x's do these two terms have in common? Well, this is an x squared. This is an x to the first. So notice they do have one x in common. So I'll just take an x by itself, and because 2x squared is positive, this x will be positive as well. How about going down this way? What's the GCF of 2x and 2x squared? Well, the biggest thing that 2 and 2 have in common is 2. The biggest thing that x squared and x have in common is just x. And because the 2x squared is positive, this 2x is positive as well. All right, let's keep rolling. How about the GCF of 3 and 3x? Well, the biggest thing they have in common is 3. Could I take any x's? Well, no, I can't take any x's because this 3 doesn't have any. And because this 3x is positive, this guy will be positive as well. So as a final answer, how can I write the area of this generic rectangle or this box? Well, I can write it as a sum of all the things inside of it, or I can write it as the product of the length times the width. So in this case, I could say x plus 1 times 2x plus 3. Now, would the order matter that I write this? Could I write it as 2x plus 3 times x plus 1? Yeah. When we're multiplying, the order doesn't matter. If you think about it, 5 times 4 is 20, and 4 times 5 is also 20. So when you write a product, two things that are being multiplied, the order doesn't matter. So in this case, if I flip-flopped it, if I put 2x plus 3 times x plus 1, it would be the same thing. It would still be correct. All right, guys, how about two more? Let's see what happens. So let's keep rolling down here. So how about C? Again, we'll start with a generic rectangle or a box. We have an X or a diamond, two things that multiply and to add. So in C, the quadratic term we have is x squared. It's going to go into the bottom left. I have negative 7 as a constant, top right. So if I multiply these two things, negative 7 times x squared, negative 7x squared. If I go into the problem itself, I see that there should be a positive 5x when they add up together. So that will go here on the bottom. So now, can I find two numbers that multiply to negative 7 and add up to 5? What are the only two numbers that can multiply to negative 7? Well, either it would have to be 7 and negative 1, or negative 1 and 7. If I took negative 7 and positive 1, they would add up to negative 6, which is not the same thing as 5x. If I took 7 and negative 1, it would add up to positive 6, which is also not the same thing as 5x. So in this case, there are no two numbers that are going to satisfy this. So what does that mean about this factoring? Well, if you remember back to the last video, that means that this part C is not factorable. So if I can't find the two numbers that satisfy, then in this case, it cannot be factored. All right, so let's keep rolling. How about D? Make a generic rectangle or box, make an X, two things that multiply and two things that add. Okay, so my quadratic term in 3m squared plus m minus 14 is 3m squared. It's going to go here on the bottom left. My constant term is negative 14. It's going to go into the top right. So very similar. This diagonal has to multiply to the same thing as this one. So what is 3m squared times negative 14? Well, negative 14 times 3 is negative 42. And this will be m squared. I know they need to add up to m, a positive m, so I can put here a positive 1m. So can I find two things that multiply to negative 42 and add up to 1? Maybe take a second, pause the video. Could you find them before I do? Well, there are lots of things that multiply to negative 42. You could do negative 42 and 1. You could do 21 and negative 2. You could do 7 and 6. And it turns out since they need to add up to something that's kind of small like 1, that means the two numbers have to be relatively close to each other. Notice they also need to multiply to a negative, so one of these numbers is going to be positive and one of them is going to be negative. So in this case, I do know that 7 times 6 is 42, but that would be a positive 42. So which one of these would have to be negative in order for 7 plus 6, which one would have to be negative in order to add up to 1? Well, the 6 would have to be negative. You would agree 7 plus negative 6 is positive 1. So in that case, I can give an m to both of these. All right, so let's double check before we continue. Is 7m times negative 6m negative 42m squared? It is. Is 7m plus negative 6m going to be 1m? It is. So then does it matter the order where I put 7m and negative 6m? It does not. So here I can put 7m, here negative 6m, and let's start GCFs. So what is the GCF of 7m minus 14? It would be 7. I can't take any m's because remember the negative 14 doesn't have any, so we can take 7 here. And because this 7m is positive, this will be positive as well. What's the GCF of 3m squared and negative 6m? Well, the biggest thing that 3 and 6 have in common is 3. I can take an m because both have 1 to spare, and because this 3m squared is positive, this 3m is going to be positive as well. How about going down this way? What's the GCF of 7m and 3m squared? Well, the biggest thing that 7 and 3 have in common is just 1. The amount of m's they have in common is just a single m. How about here? A negative 14 and negative 6. The biggest thing that they would have in common is 2. I can't take any m's because negative 14 doesn't have any. And because this negative 6m is negative, then this will have to be negative as well. So in this case, my final answer will be 3m plus 7 times m minus 2. Now, does the order that I multiply these two things matter? It doesn't. Remember, two things when you multiply, the order doesn't matter. I could flip-flop this. I could write m minus 2 times 3m plus 7 and still be totally correct. All right, guys. So here are some quick examples of using the shortcut method for factoring, which is my favorite method for factoring because it goes quick. Remember, some things are not factorable. If you can't find numbers that satisfy multiplying to something and adding up to something, then it just doesn't factor. And that's totally okay. It does happen quite a bit. All right, let's go to page 2. So what can we do in page 2? Page 2 says, can we start with 8-25? Can we talk about some special cases? So how about 9x squared minus 4? We'll start it the same way. And let's see. It says most quadratic expressions are written in the standard form, ax squared plus bx plus c. But what if a term is missing? Or what if the terms are in a different order? Consider these questions while you factor these expressions and then share your ideas with your teammates going forward. All right, so notice in A we have a 9x squared minus 4. And I'll say it this way. If you have a quadratic term and if you have a constant term, then you should still do the same thing that we did on the other side. So you can still set up a box here and an x. My quadratic term 9x squared will go on the bottom left. Negative 4 constant will go on the top right. So if I multiply these two things, 9x squared times negative 4, this would be negative 36x squared. What should they add up to? Well, if I go back up here, notice it doesn't have any x term. So in that case, what would the technical x term be? Well, it would be 0. So I want to find things that add up to 0. Well, if things add up to 0 and they multiply to a negative number, that means that they must be opposites of each other. So what opposite number is multiplied to negative 36? Well, positive 6 and negative 6. And if I add them, it does come back to 0. So I'll give an x to both of these. So here I have a 6x and here a negative 6x. Again, the order I could flip-flop if I wanted to. Now, what's the GCF of 6x and negative 4? It would be 2. I can't take any x's because negative 4 doesn't have any. How about the GCF of 9x squared and negative 6? Well, I can do 3, and I can do x. And because this x is positive, this is going to be positive as well. Because 9 and 6, the biggest thing they have in common is 3, and these both have an x in common. I could do 3x, and that's going to be positive because 9x squared is positive as well. How about going down this way? The GCF of 6x and 9x squared is 3x, and it's positive because 9x squared is positive. How about the GCF of negative 4 and negative 6x? This is 2, and it's going to be negative because negative 6x is negative. So if I wanted to write this as a product, again, I could do length times width. This is 3x plus 2 times 3x minus 2. And I could flip-flop the order if I wanted to, because remember, the order for multiplication doesn't matter. So in this case, final answer, 3x plus 2 times 3x minus 2, which is the same thing as 3x minus 2 times 3x plus 2. All right. So what makes part B different? Well, if you look at part B, you'll see there is no constant term. So let's say it like this. If there is no constant term, then just start with a GCF. So in this case, I don't need to make the box and the x because I don't have any constant term here without any x's. So I'll just do the GCF. What's the biggest thing that 12 and 16 have in common? Well, the biggest number that 12 and 16 have in common is 4. Do these two terms have any x's in common? Yeah, this is x squared. This is x to the first, so they have one x in common. So I'll take a 4x out like this as a GCF. Then I'll open up parentheses. What times 4x will give me back to 12x squared? Well, what number times 4 will give me 12? It would have to be 3. How many more x's do I need to get to x squared? Well, I have a single x to the first, so I would need one more x to get back to something like this. And I do know to double check, 4x times 3x is 12x squared. Now I see a minus sign here, so I'll drop that minus sign here. Now I'm thinking to myself, 4x times something should give me 16x. So what times 4 will give me 16? It would be 4. Here I have x to the first, and I already pulled out an x to the first, which means this term doesn't need any more x's. So in that case, I can close the parentheses. I would have something like this, 4x times 3x minus 4. And how I can double check it is I can distribute, or I can multiply inside of here. 4x times 3x is 12x squared. 4x times negative 4 is negative 16x. So there's a final answer. How would I know to do that rather than doing the other work that I did here? Because it doesn't have any constant terms. If it doesn't have a constant term, I can't fill in this top right corner, so I'm not going to do this box. I'm only going to do a GCF, and that's all I would need. All right, let's keep going and see what happens. So then how about for part C? How is it different? Well, notice that it's not in standard form. I guess a question for you right off the bat is, how could I get this in standard form? Well, I'll start with the biggest term. What's the biggest term that I have here out of all of these? The biggest term I actually have is 8k squared. Why is it the biggest term? Because that's the biggest exponent that I have for k. What's the next biggest exponent I have for k? Oh, well, that's this negative 10k. So then there goes negative 10k. Then the constant will go by itself. Because I have it in standard form, I have a quadratic term, I have a constant term. I know that I could use this method that I developed with the box and with the x. So here I go. I'll fill in what I know. I know that I have 8k squared. That's going to be my quadratic term on the bottom left. I have 3, which is the constant term on the top right. If I multiply 8k squared and 3, I would have 24k squared. If I add them up, I know I should get negative 10k, so then that should go here. All right, guys. So things are looking promising. So what will be the two values that will work here? Well, in this case, I think it would have to be two numbers that multiply to 24 and add up to negative 10. You could pause the video and try it for yourself. Otherwise, if you just follow along with me, I think we could do a 6 and a 4. And I know that those add up to positive 10, but if I want them to add up to negative 10 and still multiply to a positive number, I'll just make both of them negative, and I'll put a k on both. Let's just double check before we move on. Is negative 6k times negative 4k a 24k squared? It is. Is negative 6k minus 4k or plus negative 4k and negative 10k? It is. So in that case, I can set up negative 6k and negative 4k. All right, here goes GCFs. What's the GCF of negative 6k and 3? It would be 3. No k's because this doesn't have any. This is negative on this negative 6k, so this will be negative as well. How about the GCF here of 8k squared and negative 4k? Well, that will be 4k, and it will be positive because 8k squared is positive. How about going down this way? The biggest thing that negative 6 and 8 have in common is 2. I can also pull out a k, and because 8k squared is positive, this will be positive as well. How about going down this way? The biggest thing that 3 and 4 have in common is 1. I can't take any k's because 3 doesn't have any. Because negative 4k is negative, this will be negative as well. So if I wanted to write this as a product, I could write it as 4k minus 3. That's the length times the width, which is 2k minus 1. So that'll be something like this. All right, final answer for C, 4k minus 3 times 2k minus 1, which is the same thing as 2k minus 1 times 4k minus 3. All right, how about in D? So in D, I have 40 minus 100m. First thing I would do is put in standard form, which is the biggest term. Well, it's the biggest exponent. So in this case, I have 100m to the first. Here I don't have any m's, so technically that's m to the 0. So then here I have a negative 100m. I maybe start with that one. And here I have a positive 40, so I could do plus 40. So that would be the standard form of that right there. Is this a quadratic expression? No, it doesn't have any m squareds. So that means I don't need to set up the box and the x because it's not a quadratic expression. So instead, I would just do a GCF, very similar to what I did in part B. So what's the biggest thing that 100 and 40 have in common? Well, the biggest thing that they have in common is 20. You might think 10, and 10 is good. It's not necessarily wrong. It's just when we're looking for the GCF, we're looking for the greatest common factor. We're looking for the biggest thing that they have in common, which in this case would be 20. I can't take any m's because 40 doesn't have any. So I think to myself, 20 times something should get me back to this negative 100m. Well, what times 20 will give me negative 100? Oh, that have to be negative 5. And then notice here I have an m to the first, and on the outside I don't have any m's, so that's going to have to be an m here. Then I see a plus, so then I'll put my plus down. And then I should think 20 times something should get me 40. Well, what times 20 would get you 40? It would have to be 2. So double check it. If I did distribute this inside of here, 20 times negative 5m is a negative 100m. 20 times 2 is a positive 40. So in that case, the final answer would be something like this. So again, if it's not quadratic, if there is no m squared or x squared or an x squared term, then I know I'm not doing the x method. Instead, I could just do a GCF. All right, guys. So there's the second set of examples. We have one last question here in the bottom of the page. So let's see how it goes. I'm going to fold the page over again so I have a little bit more space to work under my document camera. And let's see what happens. So the last question that we have on the bottom of the page, 8-26, it says, turn your attention to the quadratic expression below. Use a generic rectangle and a diamond problem to factor the expression. Compare your answer with your teammates' answers. Is there more than one possible answer? So first things first, I notice I do have a quadratic, so I am going to have to do something with that box and the x. I have 4x squared minus 10x minus 6. But one little hint that I think is a good one for you is that if you can, maybe just first start off by taking out a GCF. Do you notice the biggest number that 4, 10, and 6 would have in common? Well, it would be 2. Could I take out a 4? Well, no. 4 definitely goes into 4, but it doesn't go nicely into 10 or 6. So what if I were to take out a 2? So I will start by factoring out a GCF. I can't take any x's because 6 doesn't have any. So I think to myself, what times 2 would give me 4x squared? Well, that would have to be a 2x squared. What times 2 will give you negative 10x? It would have to be a negative 5x. What times 2 will give you negative 6? It would have to be negative 3. So then double check it. 2 times 2x squared is 4x squared. 2 times negative 5x is negative 10x. 2 times negative 3 is negative 6. So then inside of here is what I'll actually do my work with. So I'll make my box like I have been. I'll make my x my diamond. I'll take the 2x squared. I'll put it down here in the bottom left. I'll take negative 3, put here in the top right. What is 2x squared times negative 3? Is negative 6x squared. I know that this should add up to a negative 5x, so I'll put that here. What are two numbers that multiply to negative 6 and add up to negative 5? It would be negative 6 and positive 1. Let's just double check. Is negative 6x times 1x negative 6x squared? It is. Is negative 6x plus 1x a negative 5x? It is. So here, negative 6x. Here, positive 1x. So what's the GCF of negative 6x and negative 3? Well, it would be 3. And because negative 6x is negative, this will be negative as well. How about the GCF of 2x squared and 1? Well, that will be just 1. X. So in this case, just an x. How about going down this way? The GCF of negative 6x and 2 is 2. I can take out an x, and because this 2x squared is positive, this will be positive as well. How about going down this way? The GCF of negative 3 and 1 is just 1. I can't take any x's because negative 3 doesn't have any. Because this 1x is positive, this will be positive as well. So it looks like if I wanted to write this as a product, the length times the width would be x minus 3 times 2x plus 1. I can write 2x plus 1 times x minus 3. We did say that the order there doesn't matter at the ends. And because I had this 2 out there from the beginning, I'll put that 2 back here. So the final answer will look something like this, which is technically the same thing as 2 times 2x plus 1 times x minus 3. So either way you write it, as long as the sets are identical to the ones we have here, would be totally acceptable. All right, guys, you have 3 questions for the homework assignment. The homework assignment is listed below on the Canvas page. Please do those questions on a separate sheet of paper and submit a picture or a PDF of that assignment. If you're having issues, email me. I have been able to help a few people kind of get over the issues they were having with submitting homework assignments. Or if worse comes to worse, just email me your homework assignment and I'll check it from there. All right, guys, you are getting credit for doing the assignments and watching the videos. So please make sure to do that every second day when we're supposed to be meeting. If you're not sure when we're meeting or what the schedule looks like, send me an email and I can let you know kind of going forward. All right, guys, thanks for watching the video. I look forward to seeing you next time in the next couple days. Let me know if you have any questions. I look forward to seeing you and hearing from you. Have a good day.